Make sure you subscribe to the Below the Surface podcast by Eclipsium in partnership with CRA. Myself and Scott Shefferman host this show, and we've had the pleasure of speaking with some amazing guests, including Zeno Kova, Richard Hughes, Vincent Zimmer, and more. We discuss topics related to firmware and supply chain security, uncovering those pesky vulnerabilities that lie, well, below the surface in your environments. You can find all the episodes and subscribe by visiting eclipsium.com/podcast or searching for Below the Surface in your favorite podcast catcher.
Welcome back to Application Security Weekly. We just talked with Heather Flanagan about the world of documenting RFCs, including a little bit of history where they came from and the ways people can contribute to them today. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. But first, you can find us on Instagram now. Follow us for highlight reels. I don't think we've ever made one, John. We'll have to think about that. Giveaway announcements and more at Sec Weekly, SEC Weekly. That's where we are on Instagram. That was obviously I use Instagram all the time, insightful type of comment. So let's ignore that, John, and talk about the news of the week, maybe something I paid a little bit more attention to. And I do have to start off with maybe two that were just kind of, they appealed to my inner Mike. One was a fun article, I hacked Magic the Gathering Arena for a 100% win rate. Now this was fun because I actually have some old Magic cards still to this day from, second edition Antiquities when that was coming out, and was just recently getting back into it because of the Lord of the Rings and the Doctor Who Universes Beyond expansions, but nobody cares about that. What they would care about is a really fun write-up about looking at protocols. And that's the other reason this was really neat, because the author here talks about how they look at network traffic. And with something like Magic the Gathering Arena, which is just a turn-based card game, there's very little states, there's very little activity that comes from the client. So it's a lot easier to handle just on the server side, unlike a first-person shooter, MMOs that have a lot of heavy client-server communication. So in a degree, it's actually a little bit perhaps easier just to analyze and reason through. And this was really neat how they how the author just went through, talked about an attacker-minded approach to this. So Dan Mayer wrote this up, and I think it's one of those things that I recommend to readers. Go read and just understand, how do other people think about software? Because that might inform, if you're a bug bounty researcher, if you're designing a client-server protocol, a state machine, how do other people look at it? What do they think of? And that can inform how you might be thinking of it as well. And then go play some Magic, because the state machine of a Magic the Gathering match can get pretty complicated once you start getting some instants and some summons and some interrupts. It's pretty awesome.
I was I entered this article excited because it sounded, the first few paragraphs, first few pages, like he was actually going to find a vulnerability in the card version of the game. I'm like, oh, this should be good. And I think that's just interesting. I think that's interesting to think about, how, this is super nerdy in a way, but how would you, is there a possibility to find protocol issues in actual physical card games and leave the tech out of it? No? Okay, well then what happens in that translation into digital and I thought that was sort of interesting. But then I had a bone to pick. This dude manages to use, I don't think it's directly an image from the card deck, but he's got an image of Sparky in there. I actually, at one point in my life, unfortunately several decades ago, got a cease and desist letter from Wizards of the Coast when I had a Magic card as an image on my website. So I'm a little perturbed about that still.
Uh-oh. All right. Well, yeah, we'll talk to Dan and get some more hacking going on. We'll keep it ethical. Don't worry. Man, this is recorded. We should move on, John. There's another article that just appealed to me very quickly. This was, yes, a directory traversal flaw, Apache struts. And if we say Apache struts, of course, people are going to think Equifax, blah, blah, blah. I will point readers back to an article we covered back in episode 256 that was actually a little bit more insights on the Equifax breach. It wasn't just, they didn't patch anything. It was, they didn't patch anything because they didn't know about it, and a few other things went wrong. There's a part of this is that I just like talking, why are we doing, why do we need file uploads and placing them on the file system in the first place? How common is this? And why aren't there better patterns for saying, here's the sandbox, thinking of Chroot, something like that, old school Unix, but that's just where my mind goes, and why I pick on or like to highlight path traversal vulns a lot. They tend to open up conversations about sandboxing, how to handle user generated content, how to where to put uploaded content. So more of a rhetorical exercise this week for me on that one.
Interesting. So this one first caught my attention when they posted it, I guess, to OSS Security. The subject was Apache struts excessive disk usage. I'm like, what? I think, yeah, you brought up a few interesting points. So quickly on the, anytime you are taking and we both know this is sort of preaching out to the hopefully the choir. Anytime you take an upload from a user versus just like a string input, there's potential for resource issues, right? So it comes down to, do you store that in temp space? Do you store it in scratch space? Do you try to keep that in memory? If you're going to keep it in memory, how many uploads can you have simultaneously? So you start running into, pretty serious issues, particularly nowadays where it's not uncommon for, if I take a photo off my camera, that's how many megabytes, and I start uploading those, and there's like me and 20 of my friends, suddenly that what was, a pretty simple upload site. Now, if you go do it in memory, do you need to start having gigs of RAM just to like store that? And then knowing the way our world works, where's the buffer overflow, and how's that actually going to come into things there? So it does become a complex issue. I mean, this is why we have things like the file transfer appliances, which have had their own little issues over the last few years. But yeah, I'm going to come back to the struts aspect of that in a few articles here. But this was. They're tough, and there's still a ton of Java use out there. But glad to see they at least caught it before someone else did.
True, and speaking of Java, maybe this is where we want to go. You did have an article here about Log4j that's still lurking around there. Hasn't fully been fixed.
God damn it. Yeah. So Veracode put out a report on the state of Log4j vulnerabilities.
Long sigh.
38% of applications out there which are using Log4j are still running a vulnerable version of Log4j. The second part which caught my attention is 79% of the time developers never update third-party libraries after including them into a codebase. So as someone who sits through application security product pitches, either from a advisor point of view or an investor point of view or a consumer point of view, my friends, do you have any idea how absolutely tired I am of hearing startups tell me about how they can detect and prevent against Log4j? So if we can't just patch our damn application, why are we spending money on someone telling us that we need to patch our application? It's like, this is going on for how many years now? This is 2 years. Folks haven't been able to patch their applications. And I get that 5, 10, maybe even 15% of apps out there, either we don't have the source code or no one's maintaining it or whatever else is going on. But if we're in a world where like you can't replace a jar file, that we're going to be happily doing this podcast for a few decades more. Come on, guys. This is just, I'm being a little ranty, and it's not really purposeful. It's just like, this is how I react to this thing. I literally sit in so many not podcasts. I sit in so many application pitches where some very well-meaning person who is trying to figure out a way to get me to buy his product is telling me, hey, I'm able to identify Log4j issues. Please do me a favor, patch your app just so I don't have to deal with that anymore. That's all. I will stop now.
That's right. Vendors, switch all of your pitches to how they can block SolarWinds, because I'm sure that's the other one that John wants to hear about. And while he's banging his head against the desk, I also wanted, on that theme, John, there was a great article actually from Forescout, who discovered a whole bunch of flaws in the Sierra Wireless Airlink routers. And I have an article here from Decipher, Duo doing great work with that Decipher news. But the thing that stood out to me is not the almost 24 vulns. I think there was one critical and a bunch of high. But I'm going to quote from the article, from the Decipher article about the use of tiny XML. Because meanwhile, tiny XML is an abandoned project that has not been maintained for almost a decade. So researchers said the upstream flaws will not be fixed and must be addressed instead by downstream impacted vendors. So, perhaps if these vendors are pitching, they can find Log4j, maybe they can start looking for tiny XML too out there. But this really is just how does I didn't have time to look up the pedigree of these Airlink routers. Like how long ago, where did they start from? When did they initially, did they take in tiny XML when it was not an abandoned project? But that brings in a whole different aspect of how do we deal with software that's abandoned. I think that's the ideal word to react to here.
So I thought when this came out, when I saw this, I thought they were acquired by Cisco, but I guess not. I must be thinking of some other wireless vulnerability which came out. Yeah, sorry guys, it's one of those days. So this has a little more leeway, at least in my mind, than just the Log4j and friends. Because if you're going to rip out a library and replace it with something else, that requires some amount of work. And I'm guessing a good number of these things are, they're air gapped, or they're somewhere far away, and it's going to be harder to update them. But still, what's next?
Yeah, and because I'd love to know just what does that need the XML for? Is that just a config file, and maybe just make it text, make it YAML, make it something else? Because not everything needs to be XML. XML is so gnarly. So there's another thing, John, that I had several articles here about AI. And now there was one about a benchmark about how do prompt injection scanners perform. There's the benchmark for evaluating the cybersecurity risks of LLMs from Meta. This is their Purple Llama. There's also an article about using AI to automatically jailbreak GPT-4 using AI. We can dive into the details of them in a second, but I wanted to talk more about the lowercase m meta of these articles in the sense of this feels like early 2000s web security. If we just talked about, here's a benchmark of cross-site scripting scanners. Here is a benchmark of the risk, like a top 10 list of the cybersecurity risks of ChatGPT-4, for example. And it sounds like we're really just reinventing a lot of the interesting to researchers part, or of just here's how to do one scanner. Here's how to look at a little tactical thing without stepping back. And I see you smiling, so hopefully we can launch you yet into another. Here's your soapbox. Rhetorically.
You're concocting a virtual world of hell. No, and this is we've briefly hit upon this, but it's where do I want to go? There's and I will forget them, but there's a sort of 5 things, and this used to be part of my pitch when I was begging people for money at Layered Insight. But if you think about apps, I'll say InfoSec in general, what I used to say is every time a new technology comes along, you're going to get 5 or 6 of these security band-aids, which get slapped on, right? So there's, the firewalls, there's the scanners, there's the intrusion detections, there's the antivirus, there's encryption systems. There's these same little separate Muppets in the circus sort of go along and sort of make money off the next thing coming. Not saying that's bad. It's needed, but it's how do we do this better? And we're seeing it now again with this. Yeah, I bet, Mike, if we went back 18 to 24 months, we probably had the same conversation around the crypto stuff. But this seems a little more, I think probably why we're seeing this is the folks that had banging on the drum of we need to improve security in AI have they've primed the field. So now everyone's going oh, we're here to do that. And I know a pretty good number of VCs out there are raising funds just purely to invest in AI security or AI in general. If we took Application Security Weekly and threw artificial intelligence at the beginning of it, we could probably raise some funding ourselves right now. So yeah, it's. I think it's worth the question. I guess comes down to it's worth thinking through. We need these type of things, but where do we improve? Do we become more refined in how we apply those tools and create those tools for these technologies, or do we maybe, hey, here's an idea. Look at those technologies a little bit earlier and go, hey, I've seen this Band-Aid before. Let me see if I can actually, make sure that the overall technology doesn't need that Band-Aid, and maybe actually do this a little bit earlier. And I know that's not how startups work, but it's maybe we'll see if it works faster this time. How about that?
Yeah, I like where you came around to that, because for me, and you were helping to elucidate what I was trying to go for, to use a nice big word, is that recreating the web app firewall for AIs, recreating the XSS equivalent scanner, the prompt injection scanner, as opposed to saying what is the framework that we could build that makes prompt injection jailbreaking immaterial, unconsequential, low impact from a design perspective. I think that's what I'm trying to express here. With that said, the articles can be pretty fun. The jailbreaking one is neat in the sense that they don't have to seed their jailbreaking tree of attacks, that they call it. It's also a tap, which is really fun. Magic reference is that it can just figure out the fun of, basically tell me how to build a bomb, as it's trying to demonstrate the jailbreak. Now, I don't think there's even any LLM out there that's going to give you realistic instructions to how to build a bomb, but it's an easy, very eye-catching metaphor for this is a jailbreak that in other terms might just be generate some abusive content, or go be racist and misogynist on a social media feed or on a customer support network. That's the equivalent of the more realistic version of the show me how to build a bomb. So I wanted to highlight that because it was a fun read. It was pretty neat to see, and still a lot of research around just the prompts and the jailbreaking that we've been covering the last 2 or 3 weeks now.
And yeah, it's I guess we could start a betting pool on how long until we see directory traversal and upload bugs in the LLMs. We should actually do that. How about we should keep an eye out and see how long it takes before we find a directory traversal.
This is perfect. And maybe also in the first CVSS version 4 for a CVE. That one I want to remind our listeners too. So let us know. John, there's Purple Llama from Meta, but there's also some other articles from Meta that caught both of our eyes around E2E encryption that's finally getting rolled out. Now, I grabbed this as just an example, a way to talk about security by design. So this is application security, that is the engineering side, the implementation and design aspect. And, I think we've talked about, I think it was NCC Group, if I'm remembering. We've also looked at Trail of Bits as well, that does some analysis of these E2E implementations with Signal, for example. And the reason I like to pull this out is it's a little bit more than just saying, well, why don't you encrypt between users? Just do some key management between end users. And that speaks, I think, a little bit to our conversation with Heather and RFCs. There is ambiguity, or there's details that have to be ironed out. How do you handle device recovery? How do you deal with spam? How do you deal with that abusive information or messages that may come through that can no longer be inspected? So Facebook, Meta does have franking capabilities, things that can opt in to say, I received some abusive material, so that they can react to it, but they can't proactively now look into this E2E, which I'll also mention brings in a whole political aspect of governments, police, legal inspection as well. So again, touching on areas that Heather was mentioning when we're talking about RFCs.
It's funny. I was just reading through on the article you had, the post from Meta. I saw a section on application security. I'm like, wow, they're actually calling us out, not us, but AppSec. And then I realized they were going in a different direction. Yeah, so the Mike got the post directly from Meta. Sorry, folks, I've got a paywalled article from Wired, which is looking at this from the point of view of why exactly did it take Meta 7 years to turn on ED? for all chats. And I think as I was sort of re-reviewing this before the show this morning, I 7 years is still a bit of a stretch. So maybe 2 or 3. Let's call it 4, and split the rest in vacation. But I think it's interesting from the point of view of like, they're starting with Signal, which existed and still exists, and it's done quite a good job and it's being well adopted. But even the point being, even though they're starting with Signal, the amount of work that Meta had to do to sort of bring it into their technologies, into their platforms, but also make it usable in a way that is acceptable for Meta's users, is really sort of where you have to start doing the head scratching and get this stuff to work. So, we often think of Apple as like the UI UX company that they care about customers and all that type of thing, and making everything pretty and easy to use. If you think about a really core thing that Facebook has done over the last decades, is they believe in that same mantra, because the easier they can make that for a user to use, you're going to get that user to use the product and stay in with it. So now you take that focus on extreme customer focus, and how do you seamlessly bring encryption into that? And then sort of the Wired article talks through like, okay, if I did this last week, the screen on my phone got cracked, so I had to replace the phone. The new phone, like, okay, I didn't see what the Facebook stuff would signal. It's like I have to go and transfer the data over to the new phone. And I did that with way too many things. But so a lot of what they were focusing on is like, how do we make that easy? And the comment I put into the show notes is, it's not just like adding 3 or 4 lines into your code to encrypt and decrypt, and maybe a dozen more for the key exchanges and rotations. It's everything else around that you got to sort of think through, and especially if you want to do it right and smoothly. So it's, again, I hate to say interesting to think about, but it is interesting to think about, and that's why we both threw this in here.
Yeah, and it's the very opposite end of the spectrum from the very old school 1998, I think, paper from about why Johnny can't encrypt, which we'll have to go throw into the show notes, about the usability of GPG. And everything you summarized was kind of why GPG is so unusable, and the considerations to make Meta's end-to-end encryption here actually usable.
That's briefly, that's... I hope the dichotomy isn't quite that wide, but I think that really sort of puts it into focus, right? Of like, any of us can use GPG. There's a hell of a lot more people using Meta's messaging platforms, and there's a reason for that.
Yeah. Before we end this, we'll see if you can go through and set up some GPG and SendMail, since that was you and Heather were having some fun trying to remember how to configure all that. Yes. But instead, maybe, John, you could tell us about Accenture taking an industrialized approach to cloud controls. This was something that feels modern, new, different, and maybe not even inspired by pure application security tech world.
Yeah, I don't know. This is one of those weeks where like the manager side of my brain was sort of picking out a little more sort of, they're not meant to be hand wavy articles, but they're a little higher level to sort of get people to step back and think about things. So this one's from CSO. I see contributing writer, so I'm wondering if there's a bit of a PR spin on this. But anyways, Accenture, long story short, when they first started going to the cloud, they let any of their developers just sort of create their security groups and do whatever. And initially it was ClickOps, and then they started doing some a little more DevOpsy type things. But what they realized, when you're in a large org doing this type of thing, what ended up working for them, whoever came up with the idea, was to use what's called the Toyota way. So for those who aren't familiar, for those who have heard this 10 million times, I'm sorry. But Toyota is known for, they've done quite a lot of things for to make manufacturing in their assembly plants to allow anyone to help improve the overall resulting product that goes out in that car on the road. They're known for, any employee can like pull the stop cord, the end-on cord on an assembly line to stop it if they see an issue. And there's a bunch of different things. There's a Wikipedia page on this. I don't think I put it in the show notes. I'll add it in. And there's actually 14 points in the Toyota way, using using visual controls so no problems are hidden, use only reliable tested technology. Some of us have problems with that one. Grow leaders who are thoroughly understand the work, live the philosophy, and teach it to others is super interesting to me. Develop exceptional people and teams who follow your company's philosophy. So there's all these really sort of, they're slightly heady, but at the same time, they're very grounded in a way. And so Accenture is sort of taking some of these concepts and applying them through to CloudSec from the point of view of like, hey, let's allow anybody to be able to have a say or make a change on what that cloud security looks like within our org. And that's sort of the base of the article where things start. I thought it'd be interesting for folks just to think about, of those 14, what are you using in your companies, big or small? I know a startup isn't going to turn around and say, hey, let's apply the Toyota way, right? That's just, we don't have 14 people. But for the larger companies that have 14 groups just thinking about this, okay, well, does this sync up with your current culture? Could you adjust your culture to do this? Do you have a better way of doing this? So I think it's just one of those things that's interesting to sit back and spend 5-10 minutes sort of thinking about. So I threw it in here with that in mind.
Yeah, and I think it's informational read, and to me, it really speaks to what we would like to see application security evolve into. In other words, it doesn't use the phrase shift left anywhere. It doesn't use any cliches. So kudos for also finding a good article that's actually focused on outcomes and what are the outcomes that seem desirable. Maybe not quite a counterpoint. There's a little bit, but related in terms of how to approach security, John. I pulled in this article from ZDNet about kernel security and Linux's unique method for securing code. Now, what stands out to me in this article actually isn't about the technical details of design, sandboxing, the adoption of Rust, for example, or using compilers to do analyzers on their C code. It's more about how do Linux kernel developers treat security bugs? And they have some, I'll say, interesting to be still judgmental, but less neutral or more neutral about approaches to this, meaning that they have a bug as a bug. They will not call out a security bug to be something more equal than others, to pull out our Animal Farm literature for the day. And they have some reasons for that. So they do. There's some justification for this, and they say, "Well, I worked on a bug before that at the time 7 years ago, it was not known to be a security bug, and then lo and behold, 7 years later, it was demonstrated to be a local privilege escalation." But that's an anecdote. I can understand that, but it still seems like the communications about security bugs does seem to not be great from the Linux kernel. And the other mention here is that, or the other thing they push is just always use the LTS kernel, always keep updating, which is great to say. Always keep updating your log4j, a bit of a callback there, but I think there's a little bit difference here between that third-party log4j and Linux kernel's stability and so on. So let me pause there and just see, what you thought reading through this in the perspective of the policies, or even the politics, we could even say, of just managing a Linux kernel, or just how this might translate to an organization dealing with their own security.
Greg KH, as he's known, has always got interesting things to say. So I like seeing his stuff and reading it when it's out there. There was a few, we both sort of I raised at a few things in this article. I think it's really interesting, and I mean, just talking about culture the way it just was, I think it's really interesting to think about the idea of, do you treat all bugs, whether they're security or not, as just a bug? And I think what that requires is you have a level of maturity in how you deal with bugs in general. So if you're at that place where you wouldn't have to have a special pair of white gloves, or get like your best people to respond to a security issue. Because I mean, usually that's reverse that around. Why do you treat a security issue separately, or a security bug in your code? Because, okay, you need to get the application security people to look at it, because obviously well, maybe not obviously, you think your developers can't figure it out by themselves. You think that it's definitely going to have a higher risk, so that's a hard one to deal with. But you think that maybe there's something special with it that you have to get like your best security person, or excuse me, your best developer. I keep saying that, or your best, like the person who knows that's particular part of the code because someone else couldn't come in and look at it. So I think it's an interesting thing about why do you treat security bugs separately? And then could you get to a point where there is that level of parity in how you treat those things? So I think that's interesting. He makes another comment in here about their security team is different than and their security team is different because they are reactive, not proactive. My friend, most security teams are reactive. But then, there's the final one, which is the group does not make announcements about security fixes, which is, I'll say, unfortunate. I think the idea of saying, hey, everyone should always keep on LTS, to me is a sign of lack of operational understanding. It's one thing for us with desktops or laptops or, even 10, 20, 30, 40 computers in the house to go through and patch them when no one else is there and reboot and do things like that. But if you're running a fleet of, let's call it 50,000 Linux instances on EC2 or, I don't know, Azure, pick whatever poison you want, and you have to go through and start rebooting all those damn things because there's a vulnerability out there or spin up new ones. When you're on even 1,000, the scale's not that bad. But for those the orgs out there that have like large number of instances or like a supercomputing farm, that's painful. If you think about it, if you've got 50,000 computers, you spend 5 minutes in each one, those numbers start adding up really quickly. And there's an article that I don't think I got it into our show notes. I'll go back. I'll make a note to look for it. Actually, I know, there's an article from Facebook for people who want to beat me to the punch, but I'll get in for next week, that talks about how they patch stuff at their scale. It would have been really interesting to compare against this one. Because it's not just stay on LTS, dude. That's a really big ask for a large org. For most of us, it's not that big a deal. But I think it's you got to think, and this is again for all of us, right? Like if you've got an application, you might be thinking about 10 people using it, but what if either 10 people are using it with 10,000 users or is 10,000 people using it? How does that change how you treat this beast? And then again, back to my original point, maybe you'd think about security fixes differently.
Great summary. I think the idea there too is also that my mind goes to scale because, as you said, there's when you start to see 200,000 systems, 400,000 systems, these are not uncommon. There's maybe 10 companies out there with that number, but that is not an unknown number, and there's still tens of thousands are still pretty messy to deal with.
I bet there's a lot more companies. Sorry, I bet there's a lot more companies with that scale than we think. Honestly, I bet it's in the thousands. But anyways, keep going.
Could be, actually. I'd love to hear it. Yeah. No, any feedback from listeners is always appreciated. Tell us if you're above that 100K level on your systems. And John, maybe take us out on something that you seem to be, I'll say, in a mood today. So I'm going to trigger that mood even more with an article that you included. So the fault is in our stars, ourselves. Death to companies that leak massively sensitive information.
Yes. So this is this is a TechCrunch article. Haji over there is he's known for having a bit of a personality in his posts. So as you can imagine, I sort of like his things. And so for those who don't know, there was a data breach in 23andMe the last few weeks. I think last week. And the result of that now, I'm not sure how widespread it is, or I haven't looked at the details, but there's personal data out there. I don't know if the DNA has been leaked or just overall. But either way, the point of this story and my sort of rant is, at what point do you basically kill a company? If they, in other words, and maybe it's never. I mean, that's sort of, it depends on how you think about this, right? Are you leading with a carrot and stick, or are you leading with a bigger stick, or are you going to try and say, hey, we learn and come back and, but even if you're doing blameless retrospectives, at some point, if your product has a vulnerability which is compromised, which is on such a massive scale that is affecting a significant percentage of the population of the planet, what are, there has, unfortunately, a lot of people in this world, they only, and this goes sound like I'm leaving politics out of it. There's a lot of people out there who they're only going to respond if they see like the penalty. So what do you do with that? Like, so in this case, in coming back to my previous rant about Log4j, the other company he mentions in here, I believe, is Equifax. So for those folks, I know it wasn't Log4j, but for those folks, Strut, does that company still deserve to exist? And yeah, it's too big to fail and all those different types of things. But so there's a philosophical think about, like, from a company scale or corporate scale, what should they, I can't remember which one he was talking about. One of these, I think, yeah, Equifax, $700 million fine. It's like, okay, that's a lot of money, but still it's a bit of a joke. So what do we do with these type of things? So bringing it back to us is from the point of view of like, how much effort is too much for us to be ensuring that our applications actually are secure. And then, what is the, what's the penalty on that? Is there such a thing as something being too secure? Do we internally, when we're working in a company, do we reach a point where we join somewhere, we like change teams and we see it, we're like, oh, we're never going to secure that. Like, okay, do we try to shut it down, or do we quit, or do we go somewhere else? Or like, do you go and reach out to the media and sort of, be that whistleblower? How do we deal with these type of things that are sort of, and I'm not talking about the directory traversal, which usually isn't that bad. It's like these large scale, like something is, the phrase I'll usually use is cancerous. What do we do with these? How do we approach them? Do we try to do chemo? How do you get how do you get from being in that position in the first place? And I think I don't think it's something we've talked about. I don't think I think it's been in my mind at some point, but this article sort of really brought it back to me. So I figured it was a good chance, since Mike brought it up, to leave us on that happy note today. Yeah, most of us aren't nearly at this place. Most of us hopefully never will be. But I think it's still worth thinking about, how do we ensure we never will be? So do we get one more tool, or do we spend a little bit longer doing the code review, or do we actually, that person who's been really stubborn about fixing this code, do we bring them out for a beer and say, hey, get them to understand it from my point of view? Yeah, that's the thought exercise for the day.
Yeah, and I think, the thoughts that I'll just tag on there at the end is that I would also hope that the approach doesn't discourage the transparency, the slow step towards transparency that we've seen from Okta, for example, and others that have suffered breaches. So, because if we have an immediate dire consequences, that's obviously an incentive to not be transparent. But we've also seen a big push from CISA about like secure by design. So hopefully there will be something we can discover about you've been negligent in your design and your approach to security versus not being a pessimist, but breaches do happen. But I don't know where we'll go from there. So maybe this is what we want to think about for the next week, John, or at least our listeners can, while we go and read some more news. And with that, John is smiling, so I think I should say thank you, John, for joining us. This was another fun week of news and our conversation with Heather. Thank you, everyone, for listening. Please do subscribe, hit that like button, check out the show notes. And speaking of the past, check out Falling from Sung. We'll see you next time on Application Security Weekly.